Okay, I want to just go over what we've already learned for the naming parts. I remember I told you that there are 4 main ways to name compounds. So the first one that we did, just to review again, was binary ionic compounds. And for that, you have the cation name plus the anion name, which ends with IDE. So for example, by the way, I forgot to mention, this is metal plus nonmetal. So this would be, the cation would be the metal and the anion would be the non-metal. So for example, CaCl2, the cation name is the same as the element name on the periodic table, and then you have the root of the anion ending in IDE. The second type was with the stock system. This applies to compounds. They're still binary compounds, so there's still only 2 elements, but they are with metals that have a variable charge. Actually, rewind that. It's not necessarily just binary compounds, but when you have compounds, the metal always comes first. So if the metal has a variable charge, and again, you can use the periodic table I gave you and check in the top right corner to see if there's more than one number listed there, then you have the cation name or the metal name plus the Roman number in the middle, indicating the charge of the cation, plus the anion name, again ending in IDE. For example, FeCl2 is iron 2 chloride. Now, for anyone that didn't understand this the first time, just to review, how do we know it's iron 2? Well, we have to look at the anion. And if you look at the periodic table, chlorine is in group 17, which means the ion has a -1 charge. And then you look at the subscript here, there are 2 chloride ions for every 1 iron ion, and the balance has to be charged. So again, iron has to be +2. Again, if you're not sure, let's just do it this way. So chlorine, each chlorine has a charge of -1. If we multiply -1 times 2, we get -2. Let's call iron X. X minus 2 has to equal 0 because overall the compound has a neutral charge. So X must be +2. And because there is no subscript here, that means that there's only one iron ion, and it has a charge of +2. So we use a Roman numeral, not numeral, Roman numeral 2 to indicate the charge of iron. Blech. Okay, the third category that we looked at was polyatomic ions. That was why I had you make your flashcards, or if you don't like flashcards and you just memorize it. Again, like I said, there's no way to learn the names and the formulas. You just have to remember them by going over and over and over again. So a couple of examples here. You have NH4Cl, and NH4 is ammonium, Cl is chloride, so it's ammonium chloride. And on the right-hand side, we have Ca bracket NO2, 2, and that's calcium nitrite. Now, when you're looking at these formulas, there's some clues that tell you what kind of system you're going to have to use. And the big clue for polyatomic ions, I've used one example of each here. On the left-hand side for NH4Cl, you have more than 2 elements in the compound. If you have more than 2 elements in the compound, that automatically tells you that those polyatomic ions are involved somehow. And ammonium is the only one that is positive, so it is the only one that you're going to see first in a formula. The other dead giveaway is having a smaller formula in brackets. Whatever is inside the bracket, that comes from your flashcards. So those are a couple of tricks that you can remember to decide in which of these systems that you're going to have to use. Now, the last one, which I didn't get a chance to talk about, was molecular compounds. And this is going to be for binary compounds, again, that is a nonmetal plus a nonmetal. And we're going to use a prefix system to indicate the number of atoms of each element in the compound. Here's the prefix system. From 5 to 10, actually, most of them come, or like most of them cross with geometry, like a pentagon, hexagon, octagon, like that kind of thing. Anyway, so if the number of atoms of the elements in the compound is 1, use the prefix mono. However, I should have put an asterisk here, because if the first element in the compound is 1, you do not use the prefix mono, and I'll show you an example on the next page of that. Di is 2, tri, 3, tetra, penta, hexa, hepta, octa, nona, deca. Again, this is something you have to memorize. There's no way to learn this through understanding. It's literally just memorizing which prefix represents which number. So, some examples. Very super common compound that you already know, CO2. Again, like I said, if the first element in the compound has only 1 atom, you do not use the prefix mono. So you would not see monocarbon dioxide. But have a look at what happens here. To indicate that there are 2 atoms of oxygen in this compound, we use the prefix di in front of the anion version of the element name, in this case dioxide. Another example, P2O5, because there are 2 P's, we say diphosphorus. Again, the first element name is the same on the periodic table, and then 5 pentoxide. Now notice that, if I can go back here, notice that the prefix for 5 is penta. But when the element name, hello, there we go. When the element name starts with a vowel, we drop the because pentaoxide is just a little bit awkward to say. So it's pentoxide. An example of where you would see mono in the name is with a cousin of carbon dioxide, which is CO. Again, carbon, there's only 1, but for the first element, we just use the element name, carbon. And this is a case where we would say monoxide. And again, because sorry, my E got cut off. Because the element starts with an O, you're not going to say monooxide. You just drop that vowel. It's monoxide. And there you have it. So all 4 ways of naming compounds in one short video.